friends, welcome back. Today we're talking about the domain of a function and finding it. I'm gonna be real honest with you, when I was in Algebra 2 and I was your age, that was back before the wheel was invented, I did not understand domain and range. I was super confused by it and I kept thinking, I'll just put down all real numbers because that's probably what it is, right? It's not. So let me give you some tips that I think helped me understand domain and range a little better. First things first, we're gonna talk about these two versions. You can, functions, remember, are just, let's back up. A group of ordered pairs is called a relation. Some relations are functions and some are not, but for all relations, you can find the domain. One thing that you need to write down, if you learn anything from this lesson, it is that x equals your input, which equals your domain, and your y is the same as your output, which is the same as your range. So when we say domain, all we mean is x. So looking at this group of ordered pairs here, if I wanted to write down the domain for this, all I have to do, remember, a group of ordered, or an ordered pair is really just an x and a y, right? So all I have to do here is write down all my x's, and you want to do that in order. So it looks like I've got -3, 0, 1, 3, 0, 3. Ooh, we got some repeats there. Remember, it's not a function if x repeats, but that's okay. For right now, we're just talking about the domain. So we would write that as the domain, and then I use these little jujut. It's like a hill and then a peak and another hill. That is for, we're going to call this set builder notation, because what we're doing is we're calling this a set of numbers. And so the numbers, 0 repeats, but we only write it down one time. Oh, wait, -3 comes first. My bad. Sorry, -3. Then we've got 0, 1, and 3. 0, 1, and 3. And that is the domain. That's all there is to it. So that's a group of ordered pairs. That's one way of identifying your domain. Sometimes you're given a table, an XY chart, and when that happens, you can say, okay, my domain is, and I do the exact same thing. I put them in order, -2, -1, 0, 1, and 2. I'm sorry, I ran off the page there. It should look like this. -1, or -2, -1, 0, 1, and 2. And again, because our domain, remember, is our x. So there you go. The next one is a graph. Now, in the case of a graph, if you're given this, to find your domain, first, backing up and talking about functions, we know if something is a function if x does not repeat, but you can also use the vertical line test, which we've talked about in other videos, but just as a reminder, if something goes through a vertical line more than once, then it is not a function. Like this would be a function, this one would not, because a vertical line goes through more than once. Okay, so domain, remember, is just your x. So here's our x. So what we do is we come in from -infinity, and the first time we see anything is right here at -2. And then we have something, I'm gonna use a pencil for this because otherwise it'll look really messy. We have something, there's something for x all the way until +infinity. So what we would say in set builder notation is the domain is, and this first part, your teacher may or may not require it, but it's x such that x is, and so that part you may not have to say, you could just say x is greater than or equal to, because there's a closed circle here, -2. Because that's where it starts, on the -2. I've been doing this 20 years and I still can't do my little braces there. Okay, now, so that's set builder notation. Interval notation says that we would say, okay, you go from -infinity, the first place we catch it is -2. So for set builder notation, or I'm sorry, for interval notation, you would say it includes -2, so I'm gonna do a bracket, all the way until +infinity. And even though +infinity is included, it's not a number, so you always use parentheses with it. If there was an open circle here, you would use parentheses instead of the bracket here, because you're saying, hey, that's not included. But with infinity, you always use parentheses. Okay, so let's talk about this guy here. Let's talk about our domain. Again, domain means x, so we come in from -infinity, and the first place we encounter this graph is right here at -3. And then again, and I'll use a pencil, there's something for everything all the way up until we get to here at +2. So as for set builder notation, you would say x such that x, oh, actually I need to back up, is, so x such that, and you would say so it's -3 to +2. So you'd say -3, +2, and then x comes in between those. Now it can equal -3 and +2 because there's closed circles there. So then you put your signs in. So this is essentially just a fancy way of saying, hey, the number comes between -3 and 2. So -3 is less than or equal to x, which is less than or equal to 2. In interval notation, you would write that it includes -3, so we're going to do a bracket, and then there's something all the way until we get to +2, which is also included, so that would be a bracket. So two different ways of writing those. Okay, now the other thing that I want, now that you're in Algebra 2, because this should be a refresh from Algebra 1, but Algebra 2, I want you to ask yourself, on domain, is there any restrictions on numbers that you can input? Can you input decimals? Can you input fractions? What about 0? What about negatives? Consider what your output will be in order to be considering what is allowed. So with that said, that sounds kind of confusing, but I promise it'll make more sense here in just a second. Okay, so the first thing is, at the beginning of this video, I said most functions have a domain of, I put down all real numbers because I started to see that most functions have a domain of all real numbers. That's not always the case, but a lot of them are. So keep an eye on that. If you're just absolutely in doubt of something, you can try putting that in. Okay, so some input restrictions to consider. Let's talk about this. All right, so let's look at example number 1 here. So if we were to put this in, so what restrictions do we have on 1 over x plus 3? Well, if you remember, we're never allowed to have a 0 in our denominator for a fraction. So if I put a -3 in here, I would get a 0 on the denominator, which is not allowed. That's an undefined, right? But can I put in decimals? Yeah, I can put in 0.5 plus 3 with 3.5, so 1 over 3.5. You can put in other fractions if you wanted, like 1/2 plus 3 would give you 3.5, so 1 over 3.5. So those are allowed. I can put in 0. The only thing that I have restricted is that I can't use -3. So the way that we would write that is x such that x equals all real numbers except x cannot equal -3. Yeah, I can't make the little. Okay, that is set builder notation. Let's talk interval notation. Now, on interval notation, we can have everything except for -3. So what we do is we write it like this. We say, okay, -infinity all the way up to 3, but 3 is not included, so I'm putting a parenthesis around that. However, on the other side of 3, all the way to +infinity, that all is included. So this is the way, this U here means union. So that is including these two things. Both of these are included in our domain there. So when you're thinking domain, the two big ones are going to be fractions and then also radicals, because for a radical, you're not allowed to have anything negative on the radical. You can have 0, but you can't have anything negative. So in that case, if I have 5 here, 5 minus 5 is going to give me 0. That's totally allowed. But if I put 4, that's not going to work. So the domain here is x such that x is greater than or equal to 5. Has to be greater than or equal to 5, because anything else, that's the restriction on what I'm allowed to put in. Because if I put in 0, I'm going to get a -5. So the way that we would write that is x is greater than or equal to 5. That means that if you were to graph this, right, sometimes graphing it on a number line helps. So this is 5, this is 6, this is 4. It's included, so we're going to do this. It's written, so the variable's on the left, so all I have to do is follow this arrow and go like this. So now it makes it a little easier to write interval notation. 5 is included, so for our interval notation, we would do a bracket for 5, comma, and then it goes all the way up to +infinity. So just like that. Okay, let's talk about these other two. So for example number 3, domain is all real numbers except in the cases of fractions and square roots. For right now, it's safe to say that. That's kind of a broad, I guess, a broad way of generalization, but for right now, that's the easiest way to think about it. So we have a fraction, so we have to worry about our domain. Remember, we can't have a 0 on the bottom here. So if it looks like this and you're like, I don't know what would make that 0, and it's making your brain hurt, you can always do this. -x minus 7 cannot equal 0. Add 7 to both sides. You get -x cannot equal 7. Divide both sides by -1, and you get x cannot equal -7. Okay, so now we know our domain. Our domain on this guy is going to be x such that x equals all real numbers except, oops, I forgot my little except x cannot equal -7. Now, the way that would work on interval notation is -infinity to -7. does not include 7, so -7, so we're going to use a parenthesis, union, -7, all the way to positive infinity. So this says, looking at this says, hey, everything's included except for -7. Now, again, for this, we have to have, it has to be greater than 0. So what we can do is say, we can say 9 minus x has to be greater than or equal to 0. Minus 9 from both sides. We get negative x is greater than or equal to -9. Divide both sides by -1. But remember, when we divide by a negative, we have to flip our sign. So x is less than or equal to positive 9. Okay, so the way we could write that in for our domain is x such that x is less than or equal to 9. And let's test that. That makes sense because 10 is not less than 9. And if you put 10 in here, you get -1. You can't have that. So there's that. And then for our interval notation, so x is less than or equal to 9. So that means it's going to be -infinity all the way up to 9, and 9 is included. Hopefully that helps you understand a little bit more about domain and how that applies that input. If you have any questions, let your teacher know. Otherwise, we'll see you next time.